Happy Saturday, space fans. I'm Anna.
And I'm Avery. Welcome to Astronomy Daily's Weekend Space and Astronomy News Wrap.
It has been another seriously action packed week in space and astronomy, and today we're bringing you the six biggest stories, two brand new ones, plus a recap of the four that dominated the headlines this week.
And we're kicking things off with something literally happening right now. A daring first-of-its-kind rescue mission that's set to launch Tuesday morning.
Stay with us, it's going to be a great one. Our first story this weekend is one you won't want to miss, and it's preparing right now as we speak.
NASA's Swift Boost mission is now planned to launch Tuesday morning from Kwajalein Atoll in the South Pacific. And if successful, it will be the first time in history that a commercial robotic spacecraft has captured and repositioned a government science satellite that was never designed to be serviced.
The mission aims to rescue the Neil Gerald Swift Observatory, a telescope that has been hunting gamma-ray bursts and other cosmic explosions since 2004. Swift was supposed to last 2 years. It's now 22 years old and still doing brilliant science.
So what's the problem? Solar storms. Recent bursts of intense solar activity puffed up Earth's outer atmosphere, creating extra drag on Swift's orbit. If nothing is done, Swift would re-enter and burn up by late 2026.
Enter Catalyst Space Technologies, a startup from Flagstaff, Arizona. NASA awarded them a $30 million contract in September 2025, less than a year ago, to build a spacecraft, launch it, and save Swift.
That spacecraft is called a Link. About the size of a refrigerator, it has 3 robotic arms, ion engines, and a suite of sensors. It rode into orbit this morning aboarding Northrop Grumman Pegasus XL rocket, an air-launched vehicle dropped from a modified L-1011. Interestingly, this is Pegasus's first flight since 2021 and its final planned mission.
Over the coming months, Link will carefully maneuver to rendezvous with Swift, grab it with those robotic arms, and fire its engines to push the observatory to a higher, safer orbit, buying it at least 5 more years of science life.
It sounds almost too audacious, and even Swift's own chief scientist admitted to losing some sleep over it.
Who wouldn't? But the fact that this mission was conceived, built, and launched in under a year is itself a landmark achievement. It's being called a template for how responsive commercial servicing missions can work in the future.
And for $30 million, a fraction of what it would cost to build and launch a replacement telescope, it's an extraordinary bet.
We'll be following Link's progress closely on Astronomy Daily in coming days. Fingers crossed for a successful rendezvous and many more years of Swift watching the universe's most powerful explosions. Our second story this weekend comes courtesy of the James Webb Space Telescope, and it is spectacular.
Astronomers have spotted what they're calling a cosmic demolition derby. At least 6 galaxies in the process of smashing into one another and merging into what will eventually become one of the largest galaxies in the universe.
The system is called TGSS J1530 plus 1049. We're seeing it as it was 12 billion years ago, when the universe was only about 1.5 billion years old. 4 of those 6 galaxies are already surprisingly massive. Together, they contain hundreds of billions of times the mass of our sun, all packed into a region just a few tens of thousands of light years across.
That makes it one of the densest known concentrations of massive galaxies from this early period in cosmic history. Astronomers call it a protocluster, the seed of what will eventually become a vast galaxy cluster like the ones we see in the local universe today. And at the heart of this galactic pileup, something even more remarkable, a growing supermassive black hole. Radio observations confirmed jets of material being expelled at high speed as matter falls into the black hole at the center of this maelstrom.
What makes this discovery so significant is that astronomers can watch both processes happening simultaneously: the buildup of a giant galaxy and the growth of its central black hole. These two things are thought to co-evolve, but catching them both in the act this early in the universe is extraordinarily rare.
The discovery came thanks to a clever combination of tools. Radio astronomers first tipped off the team by detecting unusual emissions that hinted at an undiscovered active black hole. Webb then revealed the full picture, not one galaxy, but a whole complex of 6.
The research was led by astronomers at Leiden University and the University of Oxford, and published this week in the Open Journal of Astrophysics and Astronomy and Astronomy and Astrophysics.
Another stunning chapter in what JWST is revealing about the early universe, and the reminder of just how much cosmic construction was already underway in the universe's first billion years.
Now it's time for our weekly wrap, the 4 biggest stories that had the space and astronomy community buzzing this week.
Story 1 of our weekly wrap, and it involves one of NASA's most traveled spacecraft, and a very strange little world.
NASA's Lucy mission has published new results from its April 2025 flyby of asteroid Donaldjohanson, and the findings are genuinely surprising. Published this week in the journal Science, the research reveals that this half-mile wide asteroid doesn't spin the way scientists expected.
Instead of rotating cleanly on a single axis like most solar system bodies, Donaldjohanson tumbles on 2 axes simultaneously. It flips end over end once every 10.5 Earth days, while also rocking side to side on its long axis once every 26.5 days. Scientists call this non-principal axis rotation, and it looks, in the words of the research team, like a very slow, unpredictable wobble.
In addition to its unusual motion, Lucy found that Donaldjohanson is shaped like a peanut, 2 cratered lobes joined by a narrow neck. It's what's known as a contact binary, likely formed when 2 fragments from an ancient collision slowly drifted together under gravity and merged.
And that ancient collision? It happened about 155 million years ago, when a much larger asteroid, roughly 50 miles wide, was struck and shattered. Donaldjohanson is one of the surviving pieces.
Perhaps most intriguingly, Lucy's infrared spectrometer detected iron-rich clay minerals on the surface, minerals that form only when rock interacts with liquid water. So at some point, long ago, water was present on Donaldjohanson's parent body.
The Lucy mission, led by the Southwest Research Institute, is now heading for its primary destination, Jupiter's Trojan asteroids. This flyby was officially a rehearsal, but as Lucy's lead scientist Simone Markey put it, it's already clear that no 2 asteroids are alike, and the Trojans are going to challenge everything we think we know.
We can't wait.
From a wobbling, peanut-shaped asteroid to an interstellar comet revealing alien chemistry, it's been quite a week. Let's get into it.
Story 2 of our wrap is also happening today, and it's a skywatching opportunity for those of you with a telescope.
A 1-kilometer-wide asteroid designated 1997 NC1 is making its closest approach to Earth right now, Saturday, June 27th. It'll pass at a distance of about 1.5 million miles, or 2.4 million kilometers, roughly 7 times the distance between Earth and the Moon.
To put that in perspective, this asteroid is about 50 to 60 times wider than the Chelyabinsk meteor that exploded over Russia in 2013, shattering windows across 6 cities and sending 1,500 people to seek medical treatment. The difference is 1997 NC1 was known about well in advance, is completely tracked, and poses absolutely no threat to Earth.
It was discovered by the Near-Earth Asteroid Tracking System on Haleakala in Hawaii. NASA's Jet Propulsion Laboratory has been using radar to get a close look this week, bouncing signals off the asteroid to generate 3-dimensional models revealing its shape and structure.
If you're in the southern hemisphere and have a 6-inch or larger telescope, tonight is a great opportunity to watch it drift across the background stars. It won't streak across the sky like a shooting star. It moves too slowly for that. But over 5 to 7 minutes, you'll be able to see it shift position against the star background.
It's a beautiful reminder that our solar neighborhood is not empty, and that planetary defense tracking systems are doing exactly what they're supposed to do: watching, measuring, knowing.
Clear skies to those of you with your telescopes out tonight.
Story 3, and we return to one of the most exciting objects to visit our solar system in years: the interstellar comet 3I Atlas.
3I Atlas was discovered on July 1st last year, making it only the 3rd interstellar object ever detected. It tore through our solar system, looped around the sun, and is now heading out past Jupiter, never to return. And the James Webb Space Telescope has been making the most of every moment it had.
New analysis of Webb's mid-infrared observations has confirmed something remarkable. 3I Atlas contains methane, making it the first interstellar object ever found to carry this gas. And the ratio of methane to water is much higher than anything seen in comets from our own solar system.
What does that tell us? It tells us that this comet formed somewhere very cold, far colder than anywhere in our solar neighborhood. The methane was buried deep beneath the surface as ice, shielded from solar heating as the comet first entered the solar system. It only sublimated, turned directly from ice to gas as the comet drew closer to the sun on its way back out.
The comet is also loaded with methanol, essentially alcohol, which was discovered earlier in the year, and it was itself unusual. Together, this chemistry is completely unlike anything we see in comets born around our sun.
SETI researchers also trained radio telescopes on 3I Atlas looking for signals that might indicate artificial technology. They found nothing beyond human-made interference, as expected, but the rapid response observations were valuable in their own right, helping to further characterize the object.
3I Atlas is now heading into the outer solar system and will eventually return to the interstellar void. The Webb observations represent our last close look at this extraordinary visitor. And what a visitor it turned out to be, a chemical fingerprint of a world we'll never see.
And our fourth and final story of the weekly wrap, a cosmic detective story from close to home.
Astrophysicists have announced what appears to be the first ever identified pair of sibling supernova remnants. One of them is the Jellyfish Nebula, a well-known and visually stunning supernova remnant that's been studied for decades. The other had been hiding in plain sight, concealed in the jellyfish's bright glare.
Supernova remnants are the expanding shells of gas and debris left behind when a massive star explodes. Finding two remnants that appear to share a common origin, born from the same stellar system, is something astronomers have theorized about but never conclusively identified before.
The two remnants are connected by a bright filament of gas, which the researchers believe is evidence of their shared history. The discovery suggests that the two stars that produced these remnants were once companions, a binary system, that both went supernova, perhaps millions of years apart.
It's a beautiful example of stellar archaeology, using the leftover wreckage of dead stars to reconstruct the lives they lived billions of years ago.
The Jellyfish Nebula, also known as IC 443, sits about 5,000 light-years away in the constellation Gemini. It's a popular target for amateur astrophotographers, and now it has a hidden sibling to its name.
The universe, as always, rewards those who look closely. That's the Astronomy Daily Weekend Wrap for Saturday, June 27th, 2026. What a week it's been. Satellite rescues, galaxy pileups, wobbling asteroids, alien chemistry, and the secrets of dead stars.
If you've enjoyed today's episode, please subscribe, leave a review, and share us with a friend who loves space as much as we do. We're back Monday with fresh daily episodes, and we'll be keeping a close eye on how that Swift rescue mission is going.
Find us at astronomydaily.io and follow us on your favorite platforms at @AstroDailyPod.
Until next time, from all of us at Astronomy Daily,
Clear skies.